The term numerical methods is commonly used in science and engineering to refer to techniques for approximating the solutions to mathematical models. For complicated models, you may not be able to obtain an analytical or closed-form mathematical expression, a single function like sine or cosine or some slightly more elaborate expression that can be written explicitly as the solution. And so for realistic problems, we often look to numerical methods to approximate the solutions to mathematical models. Numerical methods often involve algorithms for doing repeated processes in order to approximate these solutions, and these repeated processes are automated using computers. You can do many numerical methods by hand, but it's tedious, and so if we want to do high resolution or many repeated calculations, we're going to do that on computers. Software programs like MATLAB and Python that are designed for scientific computing have suites of built-in functions that contain these numerical methods, and they're typically organized by the type of mathematical model to be approximated. So there is a suite of numerical methods for linear equations. In Python, MATLAB is actually designed for solving linear equations, so MATLAB has some pretty concise ways to solve linear equations. Optimization algorithms encompass solving nonlinear equations, so left-hand side minus right-hand side equals 0 is the optimization problem, trying to minimize the difference and find the root. Data regression, we're trying to minimize the difference between some curve and the data that one is trying to fit or regress. And then general minimization problems, find the minimum values of this particular function. There are also numerical methods to numerically evaluate integrals and to numerically solve differential equations. There are many other categories of mathematical models that exist and other numerical methods that do have built-in functions, but these are the ones commonly encountered in science, technology, engineering, and mathematics applications very broadly.